Good morning. My name is Ian Watson, and I am the Executive Director of the American Membrane Technology Association, otherwise known as AMTA. Our intent with this series of Pioneer Chats is to record the history of the development of membrane technology within the United States. In doing so, we have been interviewing several members that took part in the early days. We intend to archive these chats with the pioneers, as we call them, and make them available to our membership so they can look and listen to some of the people who were instrumental in moving membrane technology forward to where it is today. This morning, we're interviewing two pioneers that worked for the company General Atomics Roga that invented and commercialized the spiral wound reverse osmosis membrane. And this is Pioneer Chat number 18. Good morning.
Good morning.
To my right, I have these two gentlemen. To our immediate right is Mr. Jerry Foreman, and next to him is Mr. Jack Loos. Thanks for coming. Appreciate it very much. And I know that you will fill our time with some excellent stories of your time at Roga and elsewhere. So I'd like to start with you, Jerry. Could you give us a little bit about your background, how you got involved in membrane technology initially?
Well, initially, I was a late graduate from college. Graduated when I was 29. From San Diego State. Went to a job fair, and General Atomic was there. Interviewed with them, and was offered a position. Took it. My last exam finished at about noon, and I started at Roga at 1 o'clock that afternoon. So,
what year was that, Jerry?
67.
67.
1967. And then when I went there, the first thing that happened was I had no clue what reverse osmosis was, and let alone a spiral element. And I walked in the door, and they introduced me, and then Iz Nussbaum handed me a shirt. And it was one of the very first wash and wear shirts, which happened to be a knitted tricot. And he said, "We think if you can make this stiff, we'll have a use for it." So, okay, so I took the shirt. I talked to a fellow who was kind of an internal consultant by the name of Lee LaGrange, and I said, "What would you do to make this thing stiff?" He said, "Well, you might look at epoxies," which is what I did. And eventually, we got our tricot. So that's how I got started.
Now, did you spend your whole career at Roga, or did you work?
No, there was about 2.5 years at Hydronautics, yeah.
Jack, how about you? How did you get started? I know you came from another industry entirely.
Yes, I did. I moved from Illinois to San Diego in January of 1956 and went to work for Convair and worked there 10 years. And at the time, General Atomic was part of General Dynamics Corporation also. So in 1966, I transferred from Convair to General Atomic. Worked on a little research program there for about 2 years dealing with zinc air battery development. And that kind of went kaput. And then in 1968, I believe, I went on to the Roga project and working with Jerry. That was in 68. And I was at Roga, and we were sold off a couple times to UOP and then to something else. Shell Oil Company had us a while. And anyway, I was with Roga and the follow-on companies until we got the first seawater desalination project for RO with a company in Saudi Arabia.
That was Jeddah, right?
Right, in Jeddah.
Jeddah plant.
I was a project manager on that up until a period of time when we were working with a Saudi family, the Bushnak family, and there were negotiations going on between Ralph Seaton and Zudi Bushnak to start a joint company in Saudi Arabia to design and build RO plants over there. Well, it turned out about that time that my boss and I had a little run-in, and he also had a run-in with the Bushnak family, and they backed out of the deal, as did Roga, and Zudi Bushnak hired me in the meet at that point. And I ended up working for the Saudi company for 6 years, from I think 78 to 84. And we did build a factory over in Saudi Arabia, and did all the technologies transfer, trained all their people. And 1984, they didn't need us anymore in our little El Kauthar in the U.S., so I ended up then going to work for Philtech, was it? Yeah. And stayed with them, was bought out by Dow Chemical.
Right.
And then I retired in, I believe, 1991, 92.
So good. When you both arrived at Roger initially, the spiral concept had already been developed.
Right.
But it was still, as I understand, something of a unique device in that you were still really looking for ways to employ it efficiently in systems. So can you give us a little bit of insight as to how that kind of development went along?
The backing material, when I arrived, was these little tiny glass beads that were cast on a unidirectional fabric, and I think it was latex, but was whipped up by capillary action through them, and it was about maybe a 1/16 of an inch thick, and that was to carry the water out away from the membrane down to the product water tube. Now they had the spiral design all. They knew how everything was supposed to work, but the materials were very lacking, and that was what the treacle was for, was to replace those glass beads. And I guarantee you right now, if you go down to that hangar, which is still standing on Harbor Drive, you can find a whole bag full of those little glass beads laying all around the floor, because they were all over, and it was weekly. You took somebody to the doctor to get a glass bead out of his eye. I mean, it was a mess. When I first went there, Ulrich Merton, who was the chairman of the chemistry department for General Atomic, the membrane people all reported to him. And you had Lonsdale and Riley, and they were all located what we called up on the hill at the main facility, and we were down on Harbor Drive. Ted Larson was also there. And Ted did what I consider to be one of the more, actually saved the spiral at the time. Most of the work was sponsored by the government, OSW contracts, and that's what we worked on. And if you didn't have a contract, you didn't have a job, basically. And so we were struggling, and they were making glass beads 3 feet wide. They had a contract to make a 3 foot wide element, 4 inches in diameter. It was actually 3.5, and to build an RO plant that produced 10,000 gallons a day, and that was River Valley. It was a government contract, and the monitor for the government was a guy by the name of Chana Basapa. Yeah. And they were struggling making these elements. They couldn't get them. They had the glass bead backing and 4 foot wide, and the way you assembled them, it was a tough job, and they just really struggling, and China could see that they were struggling. And he called Ted. And he said, Ted, stop the work. I'm canceling the contract. And I'll be out there in 2 weeks, and we'll write up the paperwork, and that'll be it. Ted got us together. And another thing that I had worked on, in addition to the trico, was the membrane. And it was all cellulose acetate. And the way that they were making the membrane, it always came off white. And if you looked at it under a microscope, it was white because of all these little microvoids. And I asked Burton where the microvoids came from. He says, I don't know, they've always been there. So I did a little experiment under a microscope to try to figure out where those bubbles came from. And one day I got a phone call right in the middle. I'd cast it, and was letting it air dry for a little bit. Got a phone call, went and took the phone call, came back in 5 minutes, quenched the membrane, and instead of being white, it was clear. So then I found out how long you had to go until it would stay clear. And found that out. That membrane was tough, where the other one had all the little micropores in it, was very weak. And what was happening to the spiral was at the glue line, as you pressurized and depressurized, the membrane would flex, and it would break and leak. And that's why they couldn't get more than a few hours out of the damn things if you cycled it anything at all. If you put it online and left it online, it was okay. But if you pressure cycled it, it would fail. The clear membrane, you could cycle it. And Ted got us all together after China called him. And all of us was 4 guys that could roll elements. Me, probably Al Reedinger, maybe 1 or 2 other guys. He said, what we're going to do is we're going to scrap all of the glass beads, and we're going to do the trico. And we're going to scrap the way we've always made a membrane and go to the way Jerry figured to make the membrane. Now, the way I made the membrane was a hell of a lot slower than what they did. And they said, you have to run at a certain rate or it's not economical. But if you ran at that rate, it didn't work. And the rate I ran at was about 1/3 the rate that they were running at, to get the long evaporation time, which is really the key to getting rid of the bubbles, to the micro bubbles. And that's what we did. And we put those elements together. He said, we got 2 weeks to do this. And we put in a few long hours and figured out how to roll a spiral with these materials. Every one of them leaked. At the product water tube. Everybody knows the product water tube leak. Every one was patched. I don't know who developed the patching. It was one of the rollers. And the rejection for that element, what Ted always told me when I would give him data from one of these trico elements, they'd run around 95, 96%. If you took first-time data from a glass bead element, it was always 98%. And he said, you got a leak. And I said, I don't have a leak, And what it was the embossing of the membrane. And anyway, we went with that, and we loaded it into River Valley. We picked up Chana Basapa from the airport, took him to River Valley, and showed him an RO plant making 10,000 gallons a day. And had Ted not done that, because he stuck his neck way out. He was told to stop, he didn't. And he had faith in the process and the people, I guess, and it worked.
What would have happened if it hadn't worked?
GA would not have supported it.
So that would have been the end of it.
At that point, somebody would have picked up the spiral,
Right.
clearly, okay, because it really is a good configuration for
Right.
what you're trying to do.
Right.
But at that point in time, I don't know. I probably wouldn't have worked in RO so long.
And we would never have met.
That's right. I wouldn't be sitting here now.
Now, Jack, you worked on the equipment side more than the membrane side, I think?
Yes. In fact, I worked hand in hand with Jerry. He had his casting machine and for making the membrane. And then when I got there, I remember they used to take the membrane and cut it in the lengths they needed to fold and put into the membrane element. Then they coiled that up and put it in constant temperature baths. They had to heat treat the membrane to get the rejection that they needed. And that was a piece-by-piece process. So one of the first things I was involved in, if you remember, Jerry, I put a heat treat tank on the end of the casting machine. So when the membrane came off of the drum and through the rinse tank, and then I went directly into a hot water constant temperature bath to do the heat treating on a continuous basis. So when it was rolled up off of there, it was all ready to go. Then the next step along there, part of the spiral wound element, that cellulose acetate membrane had to be supported. And it was supported by, we used a sailcloth, actual sailcloth. And so the membrane was laid on the sailcloth and then over onto the trico that he's mentioned.
You had three separate sheets.
Yeah.
So you had the
trico
membrane
in the middle, and then both sides of that was a sailcloth, and outside of that on both sides was the membrane.
Yeah.
Right.
Well,
So how thick was it? It
The
must have been-
membrane?
yeah.
4 mils.
But how thick was the envelope? It must have been quite thick.
is that two
No.
layers of membrane, 2 layers of sailcloth, and it probably less than a 16th of an inch, I would say.
20. The trico is 12 mils. 24.
Mhm.
12. The fabric was 4. You get 2 of those, so that's 8. And the membrane started off at 4 mils, but would be compacted down to 3 mils, so that's another 6. So you didn't have, it's not that thick.
Not as thick as that.
It's kind of much the same as today, really.
But when you think of sailcloth, you think something quite thick. This was obviously not.
The sailcloth was, we called it D601, came from Kenny Watts up in Los Angeles. And he was a sailmaker, and he wove fabrics for the sailing industry. But he really got interested in what we were doing.
Well, then the
go
next
ahead.
step in this development, then after we put the heat treat on the end of the casting machine, then we went up front and started feeding the sailcloth into the machine, into the casting machine, membrane casting machine. And then we cast the membrane directly on the sailcloth. So now it was much easier to handle, much stronger. And that went through the rinse bath and again into the heat treat. So now we came out with the membrane cast onto the sailcloth. Then there's another side of the trico story that Jerry has mentioned, the trico. That was the product water carrier. And it was in between the 2 layers of membrane, of course, would be compressed by the pressure on both sides. So that had to be reinforced. And that was done by, Dr. Kremen came up with,
Well, he used the melamine. We were using,
melamine.
we were using the epoxy. And the
But he came
Seamar.
up with a melamine resin that we impregnated that with. Well, when I got there, again, you were cutting these in pieces, and then they had to be cured in an oven, and they were hung in the oven and cured one at a time. And part of my development work in there then was to cut off the bottom of the oven doors and set up a system to where we could feed this treacle
And,
in through a dip of resin, through ringers, and up into the oven and back out continuously. So we continuously cured the treacle. So we had continuous on the membrane, continuous on the treacle. And part of the evolution that I kind of laugh at, started out we were making 2-inch diameter membrane elements, and then 4-inch, of course, were the big development. And then as we got into seawater, we went to 6-inch elements, and then 8-inch elements. And I remember we made a few 12-inch elements.
Mm-hmm.
And I remember I built a Ferris wheel in the hangar down there.
Another one of my dumb ideas.
Yeah, it was about 12 feet in diameter, and we strung out 20 leaves on that thing, and rolled up 12-inch elements. Well, it turned out we did make
Made a
few of them, yeah, but they were so big and heavy nobody could lift them, and they were impossible to handle.
Well, now
So-
that's the ones that went into Yuma, the 12-inch
initially.
initially.
And we,
did they?
Yeah, they did.
Yeah, no, it's Yuma.
Yeah, we only had one tube.
China Basapa said, if you want to bid Yuma, you better bid the 12-inch.
Yeah.
You have to bid the 12-inch, which is what we bid. And
Now,
our portion of Yuma was 12-inch.
when you made the 12-inch elements, did you already have a 12-inch vessel, or did you have to also develop
We
a 12-inch
developed
vessel?
that. We developed all the vessels, but nobody had a 12-inch vessel at the time we made a 12-inch,
Right.
other than steel. Now, we could make them out of steel real easy, but to backtrack a little bit, Jack, on the fabric, one of the contracts that came through there from China Basapa was to cast, one of the items was to cast the membrane directly on the fabric on a continuous basis. And China had picked that up from a grad student who had a little project that he worked on. And the grad student was Dean Spatz. And so that's just a little side story, but that's where the casting the membrane directly on the fabric came from. And I remember the first day I had all the reasons in the world why that would not work. And I came to the last thing on that contract. I had to do that, so I rigged up a roll of fabric on a casting machine. I cast it, came out, and hell, it was perfect. First time out. Rolled an element, and it was beautiful. And the real beauty of it was that you eliminated the gap between the glue, the fabric, and the membrane, because now the fabric is intimately in contact with that fabric, and you don't have that little step to go over, so you don't get the flex failure that had plagued the spiral up to that point.
Because originally you cast the membrane, and then you
The membrane was
attached it to the backing material, right?
The membrane was cast on a big drum as a film. It came off looking like a piece of polyethylene. You then took that, put it across a wire, draped it across a wire, and then you took the fabric and draped it on top of the membrane. And then you took that off, and that's what you tucked in to the treacle on the roll when you were rolling it. My estimation, that was probably the single biggest technical thing for the spiral. Because without that, you would always have this problem of failure in the future due to the flexing, the failures that you get at the between the adhesive and the membrane. And that, not only was it more sound technically, but the productivity went up by a factor of 4. And you just took a ton of labor out of it.
Jack, you moved from the what we might call the development side of the membrane manufacturing into project engineering
Yes.
for actual systems. What were some of your first projects that you worked on?
Well, Jim Slay and I got involved in running pilot plants. Seemed like all over the place. But one in particular, or two in particular, I recall, that resulted in good contracts. One was at Bridgeport Brass Company in Bridgeport, Connecticut, where the state was going to shut them down because of their disposal of a rinse water that was an acid-based rinse water.
Hexavalent chrome was the issue
Yeah.
there.
And so we built a pilot plant and took it back there, 4-inch elements, and ran it on the wastewater for, months and months. And showed that we could clean up that wastewater with the RO process. And that they could dispose of the concentrate from there a lot easier than the bulk of the rinse water that they had to use. That turned into a sizable project. I don't recall the total capacity, but the RO unit that we put in back there was about as big as this room, as I recall. It was pretty good size.
It was good. Yeah, it was 4-inch.
That was 4-inch.
4-inch elements.
Still 4-inch.
Yeah.
And the other major pilot plant operation that we did was in the basement of the Green Bay Packaging Company, a paper mill in Green Bay, Wisconsin. And of course, we were running that in December and January and February, 15 degrees below zero. Every morning we were back there. But anyway, this again was a wastewater problem. And we took pilot plant back there, and we ran it in the basement back there for probably 4 or 5 months. And that also ended up in a major wastewater treatment plant using RO at Green Bay Packaging Company in Green Bay, Wisconsin.
And they were so grateful they gave you lifetime tickets to the Packers.
Well, boy, I tell you, they're avid back there. Every bar you went into had a full-size picture of the quarterbacks and whatnot. But they're avid, yeah. Anyway, those are two of the pilot plant kinds of things we did. And then we got into the seawater membrane, and we got the biggest contract we ever had with the Saudis to build a 2 million gallon per day seawater plant?
It was 12,000 cubic meters per day.
3.7.
Yeah,
okay.
3.7.
Okay. And I was the project manager on that until we had almost everything shipped over there when only time in my professional life I had a disagreement with my boss and I ended up leaving. So.
But that was 1977, I think, or something.
That's when the
it must have
contract
been
was
about
up.
77.
Yeah.
Interesting thing is, you read in the paper here about once every week about the Poseidon project up at the power plant at Carlsbad.
Yeah.
We wrote that proposal back in 76 maybe? And that's how long that proposal has been going on, since 1976.
Yeah. Yeah.
And there's always some reason that it doesn't get built. It was just in the paper again last week. And I have my own ideas, but I won't say them.
Now, when you went from, because all of the initial membranes, commercial membranes, were 4-inch, was it difficult to go from 4 to 8, or was that kind of just a logical step?
It was just adding more leaves, actually. We took the basic leaf from the 4-inch element.
Mm-hmm.
I think there were 4 leaves in that. I went to the 6th leaf and made a 6-inch element. They were the same length. The leaves were almost identical.
You basically kept your spacing around the product water tube the same.
Yeah.
Because that was for the end user, that was a big step forward to go from 4 to 8. When the Army started getting interested in their frontline water treatment equipment, you came up with a 6-inch membrane, which was never really a standard except for the Army. How did you?
It was also used in Jeddah, I think.
Was used in Jeddah 6-inch? Was it really? I didn't know that.
Jeddah, yeah, the seawater plant.
Yes.
Seawater plant
That was 6-inch.
was 6-inch.
Now the seawater plant in Jeddah was also polyamide membrane. It was not cellulose acetate.
Yes.
How did you make the transition from cellulose acetate to polyamide?
We took the membranes that Mr. Riley gave us and put it into the spiral. I mean,
Now, did you have the same? Was it the same?
It's
same manufacturing process?
essentially.
Yeah.
That's one of the beauties of the spiral. If you have a flat sheet membrane, you can put it in the spiral.
Now, having developed the 6-inch membrane element, did you try to market that commercially to people like me when I was at Iron Water Association,
Well,
for instance?
Truth be known about the 6-inch. We also had the 8-inch developed. And we got Jeddah. The problem with Jeddah was that we didn't have a casting machine, a large commercial casting machine. The only casting machine we had was, or coating machine, I should say, was what Riley had. And that was a research machine. And right or wrong, we made the decision to do 6-inch because we figured if we had one flaw in a 6-inch, that was not going to cost us as much membrane as would have been one flaw in an 8-inch. And in seawater, it only takes one flaw.
And what was the active area in a 6-inch?
About 160, I would
Yeah.
think.
Now, while you were in the late 60s and I guess early 70s, it was really you and DuPont. There wasn't really anybody else around at that time. Although
Not to
other
speak
people-
of. You had
other
a few plate and frame people. You had
frame people.
the tubular.
You had the
with-
Ford Philco thing.
Yeah, and wasn't it Doc Havens had the tubular,
Tubular, right?
which was ultimately purchased by UOP. And I was running manufacturing at that time, so I ended up having spiral and tubular on the same floor.
Yeah.
But that's all it was. The only real ones was DuPont and Fluid Systems, and other people were getting started, but our membrane was strictly cellulose acetate.
Yeah, and as was Envirogenics when they started.
When
making
they
membranes,
started,
and Hydronautics when it started. Also, was
Envirogenics
cellulose
I could never quite figure out because we were making cellulose acetate membrane. Envirogenics is making the CA blend. And that membrane stood head and shoulders above what we could make. And they never quite capitalized on that.
No, they didn't.
I said, my gosh, you guys, you've got
Yeah.
you've got the heart of it, and it's better than, twice as good as what we can do. And they kept dinking around, I thought, but I just couldn't understand why they didn't.
I think we interviewed some of the Envirogenics folks from the early days, and I think that what I got from that interview was that even though they felt that they needed to be in the RO business, at heart they were thermal people,
Okay.
and they
Really didn't have that commitment.
they didn't have the commitment.
They sure had the membrane.
When Yuma came along, and you all piloted for some time,
Mm-hmm.
and then the proposals were submitted to the Bureau of Reclamation. Were you surprised when they selected Hydronautics?
I don't think we were surprised.
I mean, given the size of the company, it was a relatively small company.
Relatively small company, and they had a pretty good product. And as I recall, they were using the blend membrane. We were still using a diacetate membrane, straight diacetate, because we thought if we used the blend, we'd be violating somebody's patent. And I guess everybody didn't feel that way. One thing about fluid systems is we were always played it right by the, we were straight. To our problem, cost us a lot.
Yeah.
Because we wouldn't do it if it wasn't clear that it was okay to do it legally and ethically and stuff like that. And the government ends up with a lot of patents that we probably could have gotten, the Trico being one of them. Our argument was always, how can you separate government work from company-sponsored work? And you can't.
Which, of course, was the basis of the famous lawsuit with Filmtech.
Well, that's right. But neither here nor there. I mean, that's the way it was.
Yeah.
But somebody mentioned the size over there, and it is an interesting story. Cellulose acetate. We were casting membrane on fabric directly, and we were trying to take cost out of the membrane. And so I called Kenny Watts one day, and I said, Ken, what can we do to take some cost out of this fabric? And he said, well, if I didn't have to scrub it, wash it and scrub it, you could save, I don't know, 10, 15 cents a yard or whatever it was. I said, okay, can you give me some of that? Just don't scrub it? He said, sure. He sends me down a little bolt of it, and I was casting on the scoured fabric, getting 95, 96% membrane rejection. And I ran out of fabric, so I made a running splice. Put on this little roll that had not been scoured. When it came through, my rejection was 98.5. And the solution in the trough is the same. Everything's the same. And I checked it again and got the same numbers. And we chased it back, and it was what they call sizing. When they make the fabric, you have these little fiber bundles, and they put a plastic coating on the outside of it called size. They call it size. I'll probably get this wrong, but I think it was a copolymer of vinyl acetate and crotonic acid. We chased it back and found out what it was and did a bunch of work on it, and this stuff, it worked. You would lose 10% of your flow and cut your salt passage in half. We had a plant down in Florida, Key Largo, which was a partial two-stage plant. And we took the sizing down there, and within a couple hours, it was a single-stage plant, just like that. And
Wasn't the Key Largo plant was one of the first major plants for drinking water?
Right.
Yeah.
Yeah.
From brackish well water, yes.
Yeah. In fact, one of the previous interviews, we got a movie clip, that's a promotional clip for the company, and it mentioned that. It was Key Largo, 385,000 gallons a day or something like that.
It wasn't that when they started, though.
I think there was three expansions.
Yeah.
Yeah, wasn't there 3 expansions?
Well,
on that?
I don't know, but the sizing certainly
Helped.
made us look better there on that job.
There are a number of relatively well-known names in the industry that you both work with. Ted Larson you mentioned, and Izzy you mentioned, and Al Redinger, and who were some of the other people that were there at the time?
Merton, Lonsdale, of course Riley's still.
Dick Sudat.
Yeah, Dick Sudak.
Yeah.
Jerry Poole. He was in the engineering side.
Right.
Worked for Sudak.
Right.
Sudak's the guy that introduced us to the O-ring.
Really?
Yeah. I mean, and it's early, but, we did things like rubber tubing and hose clamps if you wanted to hook them in series. It didn't take Dick very long to do that, but most of the people that I reported to was a general manager.
Yeah.
So
Harry Lonsdale actually left and started his own company up
Yep.
in Oregon. Didn't he?
Mhm.
Yeah. Jack, you went to Alcaltha.
Yes.
Can you tell us a little bit about that?
Well, we were working this contract for the first seawater RO unit in Saudi Arabia. To do anything over there, you have to work with some local people. And we were working with the family, the Bushnack family, 3 brothers. And during the process of doing that project, they were putting together a joint effort proposal to form Alcaltha. And it would be a joint company between UOP and the Bushnack brothers. Well, when they then sat down and were negotiating to try to capitalize the company, our UOP people were putting price on certain things, and the Alcaltha people doing that. And finally, they just came to where they couldn't agree on anything. And I recall that Zudi Bushnack, the older brother, got up and said, well, he said, we're finished negotiating on this thing. I am going to start Alcaltha with or without UOP. And it was about that time that the Jeddah project was pretty well along, getting close to startup. And it's at that time then that Zudi offered me a job after I had a little disagreement with my boss. So we started Alcaltha. It was myself and my daughter here in San Diego and a couple of people in Jeddah. And we kept at it. They hired about 3 or 4 engineers, came over here, and we went through a technology transfer process for probably 6-8 months or longer. And then we developed a family of kind of standard RO units that, 10,000, 20,000 gallon per day units. And then we built a factory over in Jeddah in Saudi Arabia and an office complex where we had engineering then and production of the units in Saudi Arabia. And I worked with them, I believe, from 1978 till 1984. By 84, we did all the technology transfer that was required. They didn't need us here anymore in the United States, so we closed down our little Alcaltha facility here in San Diego. And at that time, I was doing a little consulting with Pete Darby for a little while then, and then ended up doing some consulting for FilmTech. And then FilmTech hired me. So I ended up working for FilmTech, was then bought out by Dow Chemical.
Right. What did you do at FilmTech?
At FilmTech, I was primarily the systems design and presentations and sales, but primarily system design, installation, startup, that type of thing.
Good. Yeah. And how would you describe your role at Fluid Systems, or Roger initially, and then Fluid? Yeah. You're a membrane guy, or an equipment guy, or not much of anything guy, or?
Yeah, not much of anything guy. I held a lot of different positions at Fluid Systems. I was never president of the company. I was for a period vice president, and that was just a gimmick to get me to stay. All other departments at some point in time either reported to me or I was in. I think that what I enjoyed most was tech service and troubleshooting.
Yeah, I remember having a lot of conversations with you about hydrolysis and silica and other things.
I really, really enjoyed that and did a fair amount of it. And we had some pretty good people there too, doing the same thing. Right. But my first true managerial job was manufacturing manager.
Right. The membranes themselves.
And the spiral, the whole manufacturing department.
Right.
And
so you managed the casting and the rolling. Good.
Casting and the rolling.
When you left and went to work for Hydronautics for a while,
right?
But not when I was there.
No,
that was after I was there.
Yeah, I had a serious problem, ethical problem, with the general manager at the time. He told me to do something that I just couldn't do. And I think it was, if it wasn't illegal, it was damn close to it. And it had to do with the government.
Mm-hmm.
Probably the same one that told me that, he said, Jack, your problem is you're confusing effort with accomplishment.
No, it wasn't that one. I think I know which one that was, too. Yeah. But that was why I left.
Yeah.
And then Hydronautics was bought by
By Roman Haas.
by the Japanese. And
This was so it was owned by Roman Haas when you worked
when
there,
I went work there.
and then sold to
sold-
Nidopenko.
Yeah.
Yeah.
And when that happened, I was director of operations running the San Diego effort, which was casting and membranes.
It was up north. It was north up on Miramar, right?
Right.
Yeah.
And they wanted somebody else to do that. And they offered me director of marketing. And I told them, no, I don't think that's for me. So stayed there a while. I went back to Des Plaines and talked to UOP, and they reinstated me, gave me all my years of service and all that back. So I went back there. I was gone about 2.5 years, I think.
Now, Jack, when you were there, you how would you describe your role? Would it be systems or?
Well, I went through a whole series of things. At Roga, I first was working with Jerry, and primarily I was involved there in the processes, the sub-processes, the casting machine, continuous heat treating, continuous treatment of the treacle material, and updating the equipment to make spiral wound, developing it to make it a little easier to make them and more consistent.
You got to remember, we couldn't buy the equipment.
Right.
We had to make the equipment.
Right.
So
and we had to do the process, and whatever it was, and Jack was very active in
that's
that.
where I got started, and probably the first 3 or 4 years did mostly work in what we call the R&D group, but doing the development work. And then from there, I got over it and got involved in doing some systems work, particularly designing and building the little pilot plants. Little, I say, 10,000 gallon per day semi-portable unit. You could put it on the back of a truck. And designing and building those things, and then evolved further into operating them out in the field. I did pilot tests in a lot of places. But notably, I mentioned before, Bridgeport Brass Company and Green Bay Packaging Company in Green Bay, Wisconsin. And then with that experience, I got then further into the systems work, and that's about the time then that Al Calther came along. So then I became more of a technology transfer person and teaching. And well, in the meantime, I also developed a seminar that I could put on for 4-hour seminar on the basics of RO, starting with what is reverse osmosis and so forth. And I put on those seminars. Kind of a neat story on that. Dave Furukawa sent me over to Japan to put on a seminar over there. And it was actually for 4 days. And they had a group of probably a dozen engineers and the head man, and I'm going through my seminar day by day by day, you know. And anyway, I remember we got to the systems part, and I was talking about systems design. Well, in Japan, before you're introduced to these kinds of things, they give you the whole background on them. That I'm married, I got 5 kids, I went to University of Illinois, bachelor's degree, mechanical engineering, and all that kind of stuff. So anyway, in the process of doing this seminar, I stood up to a chart and I started drawing a control diagram, an electrical control diagram for a system. And the headmaster says, Mr. Loos, stop. Yes, what's the matter? How do you know that? Well, excuse me, what do you mean, how do I know that? You mechanical engineer, you not electrical engineer. You can't do that. I was crossing the line. But anyway, I did put on about a week-long seminar over in Japan. So I just kind of evolved into these things. I never had any named positions, except at Elkhauser. I was head of Elkhauser here in the U.S.
Well, you have one last story you want to tell us, Jerry? Well, you were talking earlier about you had to build all of the equipment for casting and rolling and so on. But you also mentioned that earlier on that building the systems was difficult because the pumps weren't available, and you had to.
Early, they were not available. I mean, we had.
So how did you get around those kind of problems?
Well, first of all, there weren't that many systems we had to worry about. They just kept looking. We had a Rita pump, which was a well pump, and they actually put it in a pipe. If you put a couple of them in series, you could get pressures upwards of 400 to 600 pounds at a flow rate sufficient for 10,000 gallons a day at 75% recovery. So whatever that all works out to be. Right. And of course they had that super shrill thing going.
Oh, the Sundyne.
The Sundyne.
Yeah.
They tried all pumps, and they were always in contact. One advantage that we had is that our parent company was Gulf General Atomic. And they had a pretty sufficient purchasing department, and if you needed a part or something, you tell them what it was you wanted, and boy, chances were they're going to come back and have something for you that would be similar to what you needed. So that was kind of good for us. Did you ever wonder why 40 inches is the industry length?
I've always wondered that.
I thought you did. When we started out, we had this drum that measured, it was 41 3/8 across, and it was about 2.5 feet in diameter, and that's what we cast the cellulose acetate membrane on. And Ted Larson, the convention at General Atomic is that you used a drawing number to name your product. And so the first really good spiral we had was the old 4100, but that was a tape wrap. The 4101 was a fiberglass wrap, and that was a product that worked. And it was kind of a low flow thing, but it was sturdy and it could take a beating. And I think that element made 860 some gallons a day. Ted wanted an element that would make 1,440 gallons per day. and he called it the Model 4200. And that's in his mind, he called it that. Ajax had a contract with us for distribution contract for the spiral, quote, worldwide, except for the U.S. And he went up to Santa Barbara and saw Breitling, and he was always going up there, and he was the one that was negotiating all the deals. And he comes back, and it's got a big smile on his face, and says, "Boy, I've got a commitment for 10,000 4,200 elements." And we look at him, and we say, "What's the 4,200? And he says, "It's a gallon a minute." We said, "We can't do that. This is a 4-inch configuration." And so he said, "Well, we got to. I've made the commitment. We got to do this." So I can't even remember who all the technical people were in it, but I was certainly involved in it, and Al Riedinger was involved in it. And we sat down and we said, "Okay, what is the maximum we can do?" So they asked me, "Well, what can you get out of the membrane?" I said, "Well, I can get, 16 GFD at 400 pounds net. I can make it about 40 and a half to 41 inches wide." Prior to that, we were only making it 38 inches wide. And so the way that we had a trough that set on the drum, and we needed a 1/2 inch on either side to hold that trough up, because it rode on just the edges of the trough. That was the widest it could make it. So we figured out what the membrane area was. We figured out how much water we could make. And I think we put in a thinner brine spacer, slightly thinner. And it came up that we were still short on the 4,200. As a matter of fact, we were 40% short of it being a 4,200 over a 4,100. So Al Riedinger said, he said, "Let's call it the 4160. We're 60% of the way between a 4,100 and a 4,200, because that's all we can do." And that's what we did. And that was your 4,600, and there's your 40-inch length, because that was set by the width of that drum.
Width of that drum. I'll be damned. And everybody else just
followed it.
They probably thought that was
something magic to that, or we'd done a big economic study on fabric supplies and all of this stuff. It had nothing to do with that.
That's right.
How wide could you make it? There's a story.
Jack, you left Alcorta in 1984?
84, yes.
And then you went to work for Film Tech, you said, initially as a consultant, and then later you were on staff.
Well, in fact, I worked a little bit with Pete Darby right after we shut down Alcouthar in some development work there. Of course, I'd worked with Pete long before that on the original development as fiberglass, what our requirements were. But then I was consulting through Dave Furukawa, consulting for Film Tech. And he had just a little office here in San Diego, but we'd go back to Minneapolis to Edina. And it was basically just technical knowledge transfer, particularly systems work. That's what I was mostly involved in, was systems work. Systems design, all the parameters involved in doing that. And then in actual building and installation and startup of plants. So I was kind of clear across the board. But then and when Dow bought out Film Tech then, I spent a lot of time putting on seminars. In fact, a lot of time doing that.
Yeah, well, could you tell us anything about the Jetta plant that was a challenge for a problem for you to solve?
Well, first of all, one of the requirements was that all the components to go to the Jetta plant had to be able to be loaded in a C-130 because they were going to fly all the parts over there. And I remember working with Pete Darby on this thing. We had the pressure vessels, and we developed a rack to put the pressure vessels in that were called fiberglass pultrusions. And they were a quarter of a square with a circle, and we bolted these together. We made 1-foot squares out of this thing with pressure vessels clamped in there. And then we stacked those 1-foot squares 8 by 8. So we had 64 pressure vessels. And what did we make? At least 10, 12 racks of those that went by airplane over to Saudi Arabia. Now, the other interesting thing on that plant, the drivers were going to be diesel engines. Driving vertical turbine pumps was all that was available at that time. And unfortunately, I was a project manager, but I never got to see the plant in operation because I left before that started up.
I spent many a day over there, Jack.
But it worked, didn't it?
Yeah, it did. The other requirement that you did leave out, it was in the contract, was that the total plant, you had to be able to break it up into no less than 3 standalone, completely standalone operating seawater systems. Because the Saudis' initial concept was, we'll put it here first, and then we'll break it up into smaller places, and we'll stick
Take it away.
30 here or whatever, okay? Yeah. That's what they were going to do. And that was another tough design thing. I mean, not only putting it on an airplane, but to have your pre-treatment and your RO control, all your control blocks and all of that stuff had to be standalone totally.
But that turned into sort of a standard with those plastic pultrusions and the 1-foot square blocks, and we could stack those and make all kinds of designs by stacking those in different ways.
That worked
so
well.
We could go any size plant with those things.
Well, we could probably go on for longer, but time is pressing us, so I wanted to thank you both for being here. And Jerry, it's great to see you again after all this time.
Yeah.
Jack, great pleasure to meet you.
Thank you.
Heard a lot about you.
Thank you. My pleasure.
And thanks for coming, and that concludes this chat with the pioneers.